I've been kind of enjoying doing my talks recently inside of Jupyter Notebook. I've tried to press the play button thing, and that doesn't work at all, by the way. I've never gotten that to work, at least the way that I design the cells. Who here is using TensorFlow today in production? This is like, yeah, like this was like the exact same story a couple years ago when I first got into Spark. I would, everyone always does Spark Pi and all that, and then a lot of hands fall. But that's changing, of course. Who here thinks they'll be using TensorFlow within the next 6 months in production? I know. It's just funny to see everyone kind of like, How about a year in production? Okay. So just a quick intro. I think Greg covered everything, but this is the one thing that gets left out. One of my groupies up in San Francisco got me this pack of 500 of these things that look just like me, apparently. That's why I put them. I guess this is like a hip chat, right? Like emoji or something, and they just added the Cubs logo. So I've got 500. Well, I have 499, but yeah. So come and get them afterward. Started this company, was it last summer? PipelineIO. I think some people discovered PipelineAI as well and PipelineML. People were kind of poking around, so I reserved all those, which means this is legit. Yeah, I'm pretty excited about, so there's a video series. I'm actually doing an online training before the video series. It's part of Safari. This is like the O'Reilly way of like making money now, I guess, is through the subscription model. So they were doing online classes that you would pay, $2.99 or something for. And now they actually are trying to drive you to the Safari subscription. So, classic, right, like VCs love the recurring revenue. So I guess they're following that pattern. The March one's already booked, but I've got 3 more the rest of the year. Also, about to start one on distributed TensorFlow as well. Did anyone see the Dev Summit, the TensorFlow Dev Summit from earlier, was it last week or something? Yeah, it was really good. It was one of those where they didn't even pause at all. It was like there was no time for the bathroom, there was no time for anything. It was live streamed, which is the only reason I was able to go. It was really hard to get in. It was like worse than like Google I/O apparently, which like nobody, well actually I know like one person that goes to that. But this is the Meetup Advanced Spark TensorFlow. Let me click over here. We have about 6,000 people up in the city. Does anyone come to this? Anyone make the trek? Yeah.
How was parking?
Parking is usually not that good. No.
You could take the BART.
Yeah. Usually, I always plan it so that it's like near the BART. Well, mostly. Depends on where the food comes from, right? So yeah, the next talk actually I think is today. The next talk after that is tomorrow. That's a paid thing by the Open Data Science Conference. Anyone going? Anyone? Okay, it's going to be different content, slightly. So you don't have to come to my talk. But let's see. AI by the Bay conference coming up as well. This is the next big one here. So the Thursday of Strata, it's going to be like a streaming bonanza. I've got, because so many people come into town, there's people from Seattle, Google, from like Beam project specifically that will be in town, so they're coming to speak. I've got the San Francisco Flink guy, Jamie Greer. Yeah, he's coming to speak on Flink streaming. I can't get anyone to come speak about Spark streaming, and we've got meetups for the next 6 or 8 months, I think. Okay. So enough about that. Pipeline. Oh yeah, all of the code I'm going to show today, this is all open source. I'm not really good with making money, is the big joke. Yeah, I like to spend it, but here, yeah, so this is all under Flux Capacitor / pipeline. Specifically, if you want to take a look at the Jupyter Notebook, it'll be under Jupyter Hub. And just kind of drill into the notebooks, and you can reverse engineer the URL. Please don't go onto the server. I don't have it locked down, so please don't actually go there. and start running commands. This is all Docker as well too. SlideShare, all the YouTube videos and the slide presentations from past meetups, right? Because I know from like living down here, I never went to the city when I lived down here. And now I almost never come down here because I live in the city. So I've got this one other kind of bonus Docker image here that's pretty sweet. It's kind of like the Amazon, like Docker, or it's like the Amazon AMI that they have, where it's got TensorFlow and Spark, and it's all GPU enabled. And this has instructions on how to set up all the Nvidia stuff and the CUDA drivers and everything. So this is kind of fun. If you feel like burning like a few $100 on a weekend or whatever, you can go get the P2 or the like older G2s. Yeah, this is all the instructions here. Of course, you have to use the Nvidia Docker. It's just cool because you can port it, from one like environment to the other, thanks to the Nvidia guys that finally have this Nvidia Docker wrapper. So yeah, here's some instructions there. And actually, here's some quick kind of benchmarks. That's the old G2 with the 4 K520s. And yeah, now we have the like P2s. Yes, Amazon finally upgraded their GPUs like a year ago or something. So now this is the big mama here, the 16, the Tesla K80. So did some testing with this, with TensorFlow, and I think I was training MNIST or something, but yeah, the old like hello world. One thing to point out is when you do have multiple GPUs, right, the CPU is essentially taking those gradients and then averaging them, right, from each of the GPUs. So just keep in mind, there's two things to keep in mind, actually. There's this little like gotcha I found out when I was doing my performance testing where if you don't actually warm up the GPU, right, like that actually does affect the performance numbers because, right, so if you have 16 GPUs, just make sure that you cross all 16 before you start running your, there's some PTX like compilation going on and that kind of stuff.
Do they need to stretch as well before?
Yeah, and yeah, make sure your like bank account has enough money in it because yes, I left mine running and it was $2,500 I think is what it cost. Yeah, just to get this image right here, basically. Here's TensorBoard. Probably I don't know if I'm gonna have time to show that, but. Yeah, so I did this, and so this is kind of how it works here. I'll stop scrolling here in a sec. The CPU transfers the model to each GPU, right? So this is like data parallel. Each GPU then processes its chunk of the data. So think of Spark, right, where it kind of splits it up into different partitions. And then CPU synchronizes. That's the barrier there. Waits for all GPUs to process, and then all this data is being shifted back and forth between CPU, GPU, so just keep that in mind. CPU builds the new model from the gradients that come from each of the GPUs, and then it broadcasts it back out. So that's kind of like roughly how that works. In my testing, this actually wasn't linear, or it didn't follow the performance numbers I was expecting. Like was this 1,300 per second. So now this is training, right? Like examples that it's able to churn through. 4 was about 2,000, and 16 was only about 2,400 kind of thing. So I'm not really good with like performance tests. I don't, don't swear by these numbers, but yeah. And then the one image. So this is the other part of the $2,500 was like the ability to show TensorFlow can actually. If you do multiple runs, right? So I did a run with one GPU, 2, 4, 8, 16. If you write all of those metrics to the same like parent directory and then point TensorBoard to that parent directory, it'll show all of them. And you can kind of mix and match and turn them off and on. I forgot to click one of these here, I think, or I threw away the other image, but it would actually show all 5 runs of these on the same chart. So kind of slick, and actually this is an older TensorBoard. They've, well, no, actually, but yeah, they've added a lot of stuff to TensorBoard. Okay, so that was a little tangent. Who here uses Kubernetes in production? Really? Who of you do not work for Google? Well, yeah, so I guess Google doesn't even use Kubernetes. Kubernetes came out of the Borg project, right? It's kind of the next generation. Think of it like a cluster orchestrator, like a Docker container orchestrator. There's some work going on to make Kubernetes similar to Mesos in terms of fine-grained resource allocation, right? Where it's actually like a Spark scheduler, right? Like something like that. Still a little bit out there. So the way I'll be using it here is just to basically scale up workers, right? Like Spark workers at the actual Docker container level. This is kind of a slick tool I stumbled upon. It's called WeaveScope. They have tons of products. This is the open source version here. Sort of maps out your entire cluster. So let me zoom in a second, just kind of show you guys what we're. So this is actually everything that is involved in today's demo, pretty much. There's a Hive Metastore there. There's your MySQL master. There's some Presto action going on. We're going to do some load testing. Kibana, like Elasticsearch. So yeah, so basically I have all these Dockerized, and they're just orchestrated by Kubernetes. And what's cool is that Kubernetes can do all the DNS and handles all that stuff for you, so you don't have to worry too much about that. Let's see. And here's Airflow. I'm going to show Airflow today as well too. When I was first thinking about these continuous pipelines, I went straight to Jenkins, right? And then I installed the wrong version of Jenkins, realized there was a 2.0, but it wasn't really supported. And then the pipeline DSL or the workflow DSL was renamed. I don't know. I just got all confused. And
what is Airflow, or what does it do?
Yeah, so Airflow, so similar to Jenkins, right? You can kind of trigger events and have things chain off each other. People typically use that for your code builds. I'm using this process for the model deployments, right? Well, for model building and then model deployments as well. So I'll show the demo where we actually update both Google Cloud and Amazon at the same time. So it'll kick off this Airflow workflow. So think of Oozie, right? The big data world where you can actually sort of coordinate jobs, and if they fail, you can get emails and all that. It's funny because I think up in the city, right, Airflow is all the rage. There's tons of Airflow meetups and all that stuff going. I think there's an Airflow meetup down here as well too, though, right? The guy from LinkedIn that worked on Azkaban, Sid, I think, is a big contributor to Airflow. So yeah, I'll show the dashboard and that kind of stuff here in a sec. Let's see, Jupyter Notebooks. GitHub, all that stuff's there, Docker Hub. Yeah, so think of continuous deployment, not just for your code, but also, anything that can be deployed somewhere. And so I'm going to focus today on deploying TensorFlow models, deploying Spark models. I've got a couple examples of the Spark models. One of them is going to be PMML, which I know is a 4-letter word here in the Bay Area, right? I'll show a slight alternative to that, where we're actually going to do code generation, which I think these guys found and were curious. So I'll show some of the example code, which is not pretty, of course.
What are you generating the PMML from?
We are generating PMML from Spark. We've got decision tree, and yeah, from Spark ML, basically. Yeah. Okay. And then we can take the PMML and then convert it into Java code, which is kind of silly, but it actually, yeah, the performance is pretty good. So, okay. If I click too much here, this thing starts flying all over. All right, so one thing I do want to sort of get you guys to think about, this is something we did at Netflix where we would release this canary, right? And so this is code. But think of us being able to actually create a new Docker image, or at Netflix, it would be the full AMI, right? And then deploy that alongside the existing cluster. So there's 1,000 model servers that are out there serving, boom, 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 and then you push out this canary, and now, right? So there's 1,001, and now you're actually comparing system stats and things like that, and the predictive performance stats as well too, right? So you can compare these models side by side, and think of being able to do this directly from your Jupyter Notebook. So the data scientist person doesn't need the ops guy, right? Or yeah, so they could scale it up. They could, right, like tear down the old cluster. They could scale up the new cluster. So yeah, I'll show some examples of that. I'm going to talk about both, right, like the immutable like deployment model, which that process is, right, where you actually push out the canary and then like you could tear it down. But then there's also the mutable model where it's going to be those same servers, but we'll just flip the model in memory, which is like a little bit scary if like certain ones don't get the update for like whatever reason. Right now you have kind of a like heterogeneous model serving layer, which is not necessarily the worst thing in the world, but definitely not ideal.
The canary release, is canary a product name, or you're talking about
like the coal mine in a yeah, exactly. That's the right. Yeah, just kind of see how it performs. If it dies, then right, like don't pursue that path. Yeah, the other big thing I was pretty proud of myself for finally getting to it was actually integrating Prometheus and Grafana. So now Prometheus, it's a SoundCloud project, but I think it was from guys from like Google that came out and just got tired of all the metric solutions that were out there. The actual query language is like Turing complete, which is kind of funny. But yeah, like you can pretty much do anything with, and like query different stats and take rates and, combine them on the fly and everything. So let me see if, just to tease you guys, I think I have. Yeah, so this is an example here. And like once we start load testing, like we'll actually see some of these dials fire up and yeah. So there's pretty good support with Kubernetes also, and like Prometheus. Also, I'll be using my favorite library from the Netflix open source, which is Hystrix, which is the circuit breakers, right? So essentially these model servers, if you think of them just like microservices that could potentially fail, could have problems getting to like Redis or like MySQL, something like that, if you put that on like the actual hot path, you want some sort of fallback in place, right? Like the ability to serve up like a degraded state, top 10 like movies of all time, something like that. So there's a dashboard here. This is that dashboard. And this actually is going to cross both clouds here when we start to load it up. So this is every service that's out there, every like prediction service. There's TensorFlow. This one's using Redis. Here's some Python code, just generic Python code. Here's some PMML. This is generic Java code that gets compiled on the fly when we push it out. I'm going to show demos of all this here in a bit. And okay, so one thing to point out is I have a separate like training or like admin cluster, right? And then I've got a separate prediction cluster. So this particular demo, for example, Jupyter Hub is listening. It's actually sitting, I'm going to scroll up here. Excuse me for jumping. It's actually part of a separate node. And I'll show it here in a bit, but I can actually show each host, right, that's involved. So I've got 3 clusters, 3 like physical clusters. I have on like Amazon, there's the training cluster. I have a separate cluster for the predictions on Amazon, and then a third cluster for predictions on Google. So I'm doing all my work on Amazon and then deploying it to both those prediction clusters. And there's some performance differences. When I think I first talked to you, it was like Google was like twice as fast. It was like consistently twice as fast. And I don't know if they, changed, if like Amazon like flipped on the turbo button for my account or something, because I'm like, yeah, such a big customer, I guess. Maybe after the GPU weekend, yeah, they bumped me up into like the like high profile. But like the Amazon like instances have like been performing alongside for the same price per prediction, right? All right, let's go back here. Yeah, I'm trying to coin this term, extreme high availability, XHA. Anyone? No? No? So, all right. Yeah, so use it in your next meeting. So the tools that we're going to use, TensorFlow serving. One of the big reasons I actually, for the Spark and TensorFlow meetup, I sort of combine them is I first read the TensorFlow paper 2 like Novembers ago. Like they started hinting at the serving stuff and some of the distributed stuff, and these patterns are all similar, right? Yeah, we saw this just last week too with the like TensorFlow Summit, where they're talking now about fusing operators together, right? Because TensorFlow uses a DAG as well, right? Like for each operation, right? So you would do, in like Spark, you would do like a map and a filter. Spark can actually fuse those together. And now with the Spark 2.0 and 2.1, it physically like creates one Java method from those two operations, which then has benefits inside the JVM. It was able to like pipeline them before, but now it can actually fuse them. So one thing Google had announced in the 1.0 release is that same concept, but for your like TensorFlow operations, right? And then, yeah, so the other thing too was like TensorFlow serving. I really like the patterns that were coming out of here. So like they sort of split it out. Let me see, I think I have this diagram here. Yeah, I was so proud of myself for doing like a UML diagram. You know, I felt all old school. And so, yeah, it's essentially got this concept. You can you know, think of it where you would drop your model into a subfolder. Like you would start up TensorFlow serving, point it to the parent directory, and just start like dropping in different versions. And it's going to pick up newer versions and then serve them up.
Newer versions of your model.
Of the model, right. And yes, I'll demo that here in a sec too. And there's like different strategies too that you can hook into. Like there's some out of the box where it'll just take the like newest one and start serving it. There's ones where it can do them both at the same time. One of the things that they hinted during the like Dev Summit was some more like complex like features here where you can do experimentation. So one thing that actually came out in core TensorFlow is this concept of the experiment, and which I think is a scikit-learn concept as well too. So it's not really revolutionary, but it's actually like a first-class object now within TensorFlow. So yeah, I'm sure, and that's actually what like a lot of the tooling I've been working on, right? Is trying to like do like multi-arm bandit testing, things like that with these different models. Okay, so there's a few different kind of categories of model deployment as I see it. There's just like regular key value things. So think of like Netflix deploying, you know, the user ID with the top 100 movies or you know something like that. So that typically uses Redis or Memcache or you know, yeah, like could use Cassandra. And oh yeah, this key value, this is actually a like primary, it's called, I think it's just hash map in TensorFlow serving. So what was interesting is that TensorFlow typically is like a neural network library, that's how everyone thinks of it. But when it comes to the serving, they realize that you just need, at some point, right, like you might need to just deploy, right, like just like normal key value pairs. So that snuck in, and right, like you slowly see things being committed from Google, right, that they've been using, and but they've been trying to clean it up or right, like upgrade it to the latest, right, like gRPC, something like that. So, but yeah, that was actually there from the beginning. So yeah, with PMML, I mean, I've used this quite a bit. Yes, I know, like this.
Are you running the PMML in TensorFlow or as part of
Oh,
Spark?
sorry. Yeah, so this is just like another type of bundle that like you could deploy, right? Would be like a PMML bundle. Not within TensorFlow.
Okay, within
Yeah.
Spark. Okay.
The same guy that built the like JPMML, which does Spark to PMML, yeah, he's like now working on like TensorFlow to PMML. I just talked to him a couple weeks ago. And there's already a Keras to PMML. I've never used it, but right, like Keras is, well, yeah, it started off Theano. It was kind of a higher level like library for Theano, and then plugged in like TensorFlow. And one big announcement that they announced was that it's going to be not just kind of a plug-in like strategy, but they're actually going to like dig deep. So from Keras, you can actually get to distributed TensorFlow and like some of the features that like Theano doesn't have, right? Or like didn't have, right? So yeah, but just back to PMML real quick. I mean, yeah, this solves some quick and dirty stuff. There's like quite a few people using it. Yes, Airbnb has a pretty famous blog post about it where it saved them X number of hours or whatever. And then wanted to show. Oh yeah, so like obviously it's like XML and bloated. There's some some libraries out there that can actually rearrange and like simplify your PMML. So this is something to look into as well too. It can sort of get rid of, just do like the typical rearranging and constant folding and things like that. So yeah, it might be worth it if you have huge models. But now think of being able to actually take this model and generate native code. So yeah, this would be one example. And yeah, obviously this is running in sort of the interpreted mode, right? So there's a like JPMML interpreter, or like the evaluator, and it's taking in this model, it's taking in your inputs, and then like just interpreting them. Boom. Here, this could actually get like JITted and like things like that, right, from your JVM. And so the combination of like optimizing your like PMML and then the ability to actually like generate optimized code this way and sort of simplify cases and things like that is pretty cool. Although some people, yes, I understand like it would be a little bit, it's like so many like layers, separate from like the original Spark ML model or like whatever that you're dealing with there. All right, so, and then there's like TensorFlow. So yeah, TensorFlow kind of has its own thing going on here. Think of like a static graph, and then there's the weights that are trained. So typically, when people say model, it's kind of a directory, right? It's one static graph, and then there's a separate file that can continue to get updated, right? Because with these neural networks, you can continuously fit, right, like partial fit kind of thing over and over and over. You might not want to for like overfitting reasons, but that graph stays separate. And at some point, though, like when you go to serve it, right, like you have to, so there's this tool called freeze graph that can actually take what used to be a variable in the graph and now make it a constant from the most current checkpoint. And so now you can actually do just the forward prop and then really do the predictions. So this is actually where quite a lot of optimizations are really going into things here, because you can do other things. You can strip out certain nodes from your static graph that aren't used during like the scoring or the predicting side of things, like dropout, like your summary writers, which is actually writing so that TensorBoard can show the graph during training, right? But like you don't need these things at serving time. So I'll show a couple more of those here in a sec. Different model deployments, mutable, and so yeah, these have different rollback like capabilities, right? So at like Netflix, we would scale up the new, we would first push out the canary, scale up the new cluster. Now we have 2 clusters. We would flip over the load balancer, and now we're spending thousands of dollars, right, like just to make sure that if we need to, we can roll back with full confidence and have full scale, right? So, but for 8 hours, 10 hours, something like that, like there'd be a second cluster of the old right, like code running. So that's the safest way to do it, right? Like obviously our goal there was to minimize like customer downtime, keep the experience up. That's not always an option for like a lot of companies. Okay, so other ways to optimize your TensorFlow model. So this is kind of the older way of doing it. But what's happened, so this guy, Pete Warden, he specializes in running TensorFlow on mobile devices, right? So like Google bought his company, I think he's out of London, because, right, like he just understands, right, like the Android devices, right, like small devices, that kind of thing. So yeah, his blog is actually really good. He's got an example on how to deploy TensorFlow on iOS. I believe Android as well too. It's called, but in doing this, right, like he needs to be able to get that model size down, because if you just, Can
you access this, your presentation?
Yeah. It is under, if you search Bay Area on the flux capacitor repo. So go to this repo and just, actually, this is always my favorite. Do you guys know about T, the T command in GitHub? If you don't, this is going to change your life right here. If you're on this code tab, you can hit T and just start typing, Bay Area ACM. Bay Area. All right, well, that one didn't. What is it? ACM. Oh, you know what? I haven't committed this yet. Yeah, that's what it is. But that will take 2 seconds. Live presenting, always fun. All right. Yes, I do want you guys to be able to see this stuff.
You don't have to do it live.
Okay.
Afterwards, can you post it on the Meetup? A
Absolutely.
couple of links where people can find the content afterwards.
Yeah, so is that good enough?
Yeah, that's good.
Is that okay? Cool. Did I lose my sweetness here? Okay. So in trying to make these models small enough and fast enough to run on these like smaller devices, right? That's the whole like use case here. So there's like different techniques. Like there's like this sort of older way of doing it. It's still around because people use it, but you could strip out parts of the graph that are never reached, right? Yeah, training only operations like checkpoint saving, right? You could do batch normalization folding, right, like fusing like different operations. So like this was kind of the first attempt. And then in doing this, they realized, well, wait a minute, like we can create this like this whole graph transform tool that can do lots of stuff. So let me show you a quick glimpse into that. And yeah, this is Pete Warden, his group here. Yeah, there's other techniques too where you can train at full precision, but then once you actually have those weights, then you can, yeah, because this is all kind of fuzzy anyway, right? Just sort of lop it off, go down to 8-bit ints, right? Like retrain, and then, yeah, so you can cut, 2/3 of your model. Like I've seen models go from, was it 90 meg down to like 22 meg, right? Like that kind of stuff. Performance on a CPU isn't really all that much better with the forward prop, right? But what you can do is start, yeah, so one thing, I'm working with a like customer right now where we're actually doing the on-device, right, like scoring, and at the same time firing up, right, yeah, so this is all kind of experimental. At the same time, right, like firing off a server-side call to get like the actual, right, like better precision, like prediction, and then sort of comparing those and seeing how things are going. And then we can dynamically just keep using the one that's on the device, right? Yeah, so there's some cool tricks you can play there. So yeah, shrinking file size, 8-bit quantization. And then here's kind of a whole host of these. So yeah, some of these we saw in like the older script. This is a lot of what the video series will cover, and like the online training. There's things like, so during training, right, like you can actually specify GPUs. So there's different operations to do that. But when you're actually serving, scoring, and right, like you don't have access to a GPU, then you can sort of disable those operations, just go straight to the CPU. There's this nice framework too that you can actually write your own transformations. So that is probably going to be the finale of that video series. Yeah, just doing like a simple transformation just to sort of learn the framework. So yeah, check this out. In order to do all this though, right, like your graph needs to be frozen, where you combine the two. Yeah?
Is this all for doing the prediction on local device?
Repeat the question.
Or is this still for doing the cloud?
Is this, okay, so the question is this, oh, wait, so these transformations, you mean? Yeah, so are these transformations just for like on device or also for cloud? Yeah, so this is anywhere, right. The thing is that if you do have GPUs and things like that on your, right, like on your, right, like cloud service, right, like you want to use those. So you would just be more aggressive on the actual device, yeah, like the version that you deploy to the device.
So what is the main application for it to do it in the cloud, or is to do it?
You would do it in, so the actual transformations, Right. So the question is, I guess it's the same question, right? It's like where are these transformations meant to happen? Is that the question?
The target deployment. Is
Yeah.
target deployment like a mobile device or a cloud or something with a GPU in the cloud?
Right. Yeah. I mean, you have full control, right? If you know the like target environment, which you likely do, then you would keep those GPU right like operations in there and yeah, that kind of thing.
No,
Yeah. So you can choose.
Is it getting important for the industry to do it on like your mobile phone with connection, or why doesn't it just go to the cloud and do it?
Oh, I see. Yeah. Yeah. I mean, there's some stuff. Yeah. The question is, where are these predictions happening? Like typically, right? Like where, and like why are we even bother? Yeah. So why should we bother to try to optimize if all predictions are happening in the cloud? I mean, I guess the sort of general trend would be, right, that these devices are becoming more and more powerful. So why would we go to the cloud, right? Like why do we take that, yeah, that latency hit, or right? I mean, yeah. All right. So yeah, here's an example of where you would transform. This is the generic tool. You give it the input graph, give it the optimize, just like a name of the output. One thing that is kind of goofy, even with TensorFlow serving, especially before 1.0 TensorFlow serving, was like this way to sort of map the inputs and the outputs, because of course when you go to score, you have input, right, like values, right, that you're trying to pass in. Like you've got like the square footage of your house and number of bedrooms and that kind of thing. So how do those map to the inputs? And some of these TensorFlow names, if you're not careful about how you name them, get really goofy and right, like there's a pattern to them. It's just you kind of have to know like the like type of like operation that it is and things like that, and then it just sort of it goes from 0 up to n or whatever, right? So one best practice is during training you should name your actual inputs, name the outputs. With TensorFlow 1.0, there's a way to like keep that mapping. There's a logical name. That way, if you do, and that's what the serving code actually uses. If you do change your graph, you just change that like logical mapping, right, to the new physical node name for your input. Yeah, so before it was pretty brittle if you if you just like this, or if TensorFlow started to generate something different, right, like now your scoring was all messed up. And so what you do with this new generic tool is just pass in a list of transformations, and out comes the optimized. So now one thing, yeah, like these Google guys keep getting flack about this, is that, right, like these optimizations don't really like take effect on your server version of the, So if you compare, right, like performance, right, that's not on, yeah, so there's two things. So, right, like comparing CPU server to GPU server, like there's a huge speed up. If you're comparing, right, like an optimized on a CPU to an unoptimized on a CPU, there really isn't that much speed up, right? So, like they're sort of building this stuff for like the extreme case of using GPUs or the on-device. Yeah. So I guess like that sort of addresses that like earlier question.
But the optimizations are good for the convolutional nets, not so much for the language.
Yeah. Right.
So
Right.
the
Right.
language stuff, from what I understand, doesn't really get speeded up that much for
Right.
the GPU.
Yeah, so the question is, right, like where do these optimizations actually work? Like which type of models do they actually work better for? And yeah, so convolutions, the speech stuff, yeah, like do you know why that is? Why it doesn't?
Well, the convolutions work because they just vectorize much better. I think if you were to solve the general purpose problem of customer attrition
Yeah,
as a backprop net, only with more layers, I don't think it has as many millions of vectors as a convolutional image net type of thing would have.
gotcha.
So where you do all the image processing, video processing, those convolutions are what benefit from the GPU.
Cool. Okay, and then yeah, here's kind of a fancy tool that you might want to use here is the summarize graph. This is new. I think this is new as part of 1.0 or yeah, maybe even like the version before, but There was another tool that would kind of show you the inputs and outputs, and there's a way to like inspect the like checkpoints, which are the actual weights that are learned, things like that. That was good for when you were trying to figure out why that like input name changed, and now like you're not scoring anymore. So yeah, just keep an eye on those. All right, so this is the other big thing with TensorFlow 1.0 is this XLA compiler. So this actually, it's sort of in like two different forms, right? It's like just-in-time compiling, which is something that like we're all pretty familiar with. But then also there's this tool tfcompile, I think is the latest term for it. This can do like the full, like the AOT compile, right? Like the, so the XLA happens at runtime, and this is actually a tiny bit tricky to get installed. There's like one thing, like there's one little checkbox you have to check when you're installing, but if you're trying to install TensorFlow serving, things get kind of weird. So I've got all that solved in these Docker images and that kind of thing. So yeah, this is something else we're going to explore, but again, even at the summit, right, like they admitted that if you're comparing CPU to CPU, or if you're comparing optimized model to an unoptimized model on a CPU, right, like you typically won't see too much gain. Like you'll see smaller size, but not necessarily faster. Also, there's been quite a bit of work on like compressing ensemble models, right? So that's all like the rage now is the ability to score separately and then sort of average the results, things like that. So there's some post-processing that you can actually merge those two, and it improves the scoring time a bit. Let's see. Something that is actually pretty significant, and this is noticeable, even on CPU, is the ability to do request batching. So this is the other good thing that I liked when I was reading, first reading about TensorFlow serving, because this is something I've experimented with, and I've got a demo where I'm actually, let me just show you guys the picture here. So picture if there's two different, so there's matrix by vector, but now these are coming from two different clients, right? So think of two different devices. The server, so this is TensorFlow serving. This is the actual C++ process that gets both of these at, like within 10 milliseconds or like something, right, that's configurable. And so this is the ability to actually create one big matrix by one big vector and just sort of padding zeros here, keeping track of the offsets so that when you do get the result, so pass all that into the CPU or the GPU, which would rightly be even better, and get, so just get one result. And because you know the offsets, you can actually send this back to the original first client and then send this part back to the second client. So this is all handled for you by TensorFlow serving. I built a version, so Hystrix, which is the Netflix open source library. Yeah.
Is that a speed advantage? Because
yeah,
it's a one matrix versus two.
It's a trade-off. It's the classic trade-off of throughput, right, like versus latency. So if you have if there's low throughput, just do regular, and it'll be 1-2 millisecond, right, like responses. But if you want like super high throughput and do 5 milliseconds, 10 milliseconds, yes, I'll show the demo where things actually come in like right at that number, obviously, right? So, yep.
Why do we need another vector of 1, 2, 3, 4? Is that something we assign or it's?
Oh, so it's
that's
this times that. Yeah, right. The numbers kind of conveniently, consecutive. It was just the example we used. I was like talking to my buddy over like text on this, and I was like, I don't quite understand it. Can you? And he took a picture and texted it to me. So yeah, linear algebra over text message. That's a great thing. So yeah, classic trade-off. Also keep in mind that the deeper the model you have, the longer the latency. So think of this when you're doing your canary deployment, right? So if the data scientist has a pretty shallow model and then decides, oh yes, I want to add another 10 layers because obviously, right, this is going to classify better or learn this pattern better, this function. But now it's taking 15 milliseconds, right? So this is something that you would want to keep an eye on when you actually deploy the canary. Like you'd want to pull up either Grafana or pull up something like this where you can actually see right, the 90th percentile, 99th percentile. If the canary is way out of line, right, then you have to pull that thing down, because or add more servers, or do right, like something. So that's one of the metrics that people seem to get excited about when I'm explaining to these data science teams, right, like this ability to actually see your own models in production and see the performance aspects. They don't necessarily care about heap or anything like that, but if heap is an issue, or right, like memory starts to blow up or something like that, they right, like throw in just like a whole ton of new right, like word embedding, something like that. Yeah, that's something that they want to see. So yeah, so data scientists love data. Yeah, they like dashboards, right? So yeah, why not give them performance stuff as well? Let's see. Okay. Yeah, so keep an eye. Memory, when you're dealing with natural language stuff, you're going to have some problems with the size of the word embeddings being right, like gigantic. So there's tips you can do, right, like using hash ID, where you could have collisions, but again, this is all kind of fuzzy anyway, right? Let's see, parameter servers.
Is that hash ID a lookup table to the 300-dimensional input?
Yeah,
of the word?
yeah,
Okay.
yeah. All right, so let's kick off. So here's a TensorFlow model. I'm picking a pretty simple one here, so I'm just importing. This is some fancy JavaScript here that's going to let us actually show TensorBoard within the notebook cell itself. Let me see here. Let me change this version. So here's the code. Code's not really all that interesting. All right, so what we did here was we actually trained this model. And the output is a directory. So this is the full directory here. I think and here's the actual fancy JavaScript. So this is TensorFlow, or yeah, this is TensorBoard. So you can see, right, like the operations here.
Can you get rid of the left margin stuff?
How do I don't think I can fit
Or scroll
to screen.
to the right?
Yeah. All right, and so this is kind of it's sort of a thought experiment here. So what we do is, let's print it out. Okay, we have directory 29 there now. So what we're going to do here is actually commit this model to GitHub. Yeah.
Where was that model trained?
It's trained, yeah, so in Jupyter Hub, there's yes, I have TensorFlow installed there. Yeah, just it's a single node TensorFlow just running inside of the like Jupyter Hub.
What was the library called?
Docker container.
TensorBoard inside Jupyter?
Yeah, there's this, yeah, the question is, what is the JavaScript function, or yeah, like Python function. So within like Jupyter like notebooks, you can actually render, right, like iframes and things like that. So yeah, this is just doing a fancy, it's just generating JavaScript, yeah. I just found it on Stack Overflow. It wasn't anything fancy. Yeah, but I think, right, like your question is, where is this model actually being trained, right? I'm like hitting Shift-Enter within, right, like the notebook. This has to go to some TensorFlow server somewhere. This is, so for like this demo, this is a single TensorFlow install that's actually installed on the exact same Docker container as like Jupyter Hub. Yeah, so ideally, though, this would fan out to a distributed cluster, right?
So this is your Docker Hub running on some server?
Yes, this is running. So here's a live version of that Weave scope thingy. And this thing gives me all kinds of trouble trying to center it. Yeah, this is actually, so Jupyter Hub is going to be one of these Docker images. And how this maps to the code, let me show, where is it? It has to be here because I'm running on it. Jupyter Hub. Is there a way to search? Oh, yeah, there's a way to search. There it is. Yeah, so this is, and so how this actually maps to the code within the repo is you can go here, click on that, pipeline. It's going to be jupyterhub.ml, and there's a Docker file in here that has everything. Yep. It's pretty nasty. Yeah, it's got everything under the sun. For the demo purposes, yeah, I've got Spark on here, and I've got just single node everything, right? Actually, that's not true. For Jupyter Hub, when it's using Spark, it actually goes to like a full Spark cluster. Yeah. That we'll scale out here in a sec. So one cool thing about this tool is that you can actually hop into the Docker container and start like running commands, right? Oh. That one's not working, but, or you can, yeah, right, like you can look at the logs, things like that. Yeah, that's been broken for a while. I keep forgetting to, I don't really use it that often. I just use, it's basically just doing Kubernetes and just, right, like issuing the same commands that the Kubernetes thing would do, which is, right, like very similar, right, like not surprisingly, very similar to the command line for Docker itself, right? There's kubectl exec, kubectl, right. Yeah, I mean, each of these have been running. Yeah, so the question is, like, how long are these Docker containers up for? I think when I checked this morning, 40 days. Yeah, some of them have been up from, I just keep it running all the time, right? But I could tear it down. Yes, I'll show in a sec here scaling up Spark. Yeah, so we'll actually add Spark workers, right, like dynamically, and then we could tear them down.
Is Docker in AWS?
Is Docker? Yeah. So.
What kind of Docker's containers storage strategy?
Yeah. So the question is, or yes, I'll like sort of rephrase the question is like, what's sort of the way that you deploy Docker containers, right, on these clouds? Yeah. Yeah. So. Yeah. So this is all Amazon. This is all Google. So I'm using Google's Google's container engine, which is actually GKE, and I think the K is Kubernetes, right? Because GCE is their compute engine. ECS doesn't have good support, or at all. There's no support for Kubernetes itself. One thing I liked when, I did a recent POC on, and right, like the client used Azure, and I was all scared. I was like, oh man, I can't even like remember my Hotmail password, from like 10 years ago. But once I got in there, there's like first-class support for Kubernetes. It's just another drop-down, right? Like, do you want their, scheduler? Do you want Mesos? Do you want Kubernetes? So the sort of joke is that when you're dealing, if you're trying to run Kubernetes on Amazon, there's all these scripts and all these tools and everything you have to run. Yeah, it gets a little hairy. As a like related point here, I should point out on the wiki, I've got instructions to get all of this running on, all three of these, right? The three big clouds. So once you get Kubernetes set up, now we actually deploy PipelineIO on Kubernetes, and it doesn't matter where. Right?
So in terms of storing...
The question is, right, like where is my persistent storage, right? So not just databases, right, but also if I'm like creating models, right, like where do I... So the way I'm doing it, here is I'm actually committing it to GitHub, and then that triggers like an Airflow through like a webhook, right? And now, I'll show Airflow like kicks in and it starts. Actually, let me get it started because it takes a bit. And then, that actually goes and deploys to both clouds, right? But your model ultimately, it's just in like GitHub, right? But I think this is a larger question of how do I do persistent storage with containers, right?
It's like you are using GitHub as S3.
Yeah, which is, I would not recommend that at all. It's just, grokkable, right? And it's like somewhat straightforward to set up. These webhooks are really well documented, things like that. It's kind of the same question when we moved, off the data center into right, like Amazon, and we have these ephemeral AMIs and things, right? So yeah, like we would use S3 and that kind of thing. Yeah, Kubernetes has support for S3, for the Google persistent store, all that kind of stuff. All right, so long story short here is all of this happens, let's see, boom, boom, okay, boom, oop, 29. And I should be able to commit where did it go? This is the directory here. Okay, boom, boom. Yeah, so here I've set it up. Yeah, I'm just doing all this in, right, like, it's kind of janky because this is all within the actual notebook itself, but. And then there's one other janky thing here too where I can't actually push from within the notebook for whatever reason. So I'm going to do git push.
As you go through this, can you specify, differentiate between what you're doing because it's convenient for a demo and presentation?
Yeah.
Versus best practice for people
Yeah.
building and best practice for people putting things into production and managing production?
Right.
Like, are people using Jupyter much to manage things in production, or is it just for a demo tool?
Right. So I definitely would not use GitHub as your primary source, right? So think of this, similar to what was it, like the Amazon EBS service from like a few years ago when everyone was all scared of EBS because it would go down. If you were like baking AMIs and then putting the AMI onto EBS and then you lose EBS during like a huge outage, now like you can't even generate or so roll back to like older versions or start to scale out because now you've actually lost your like primary source. So I mean definitely use something like a little bit more stable, right, like S3. So GitHub goes down like relatively all the time, right, like relative to like other like production systems. But I guess the thing to take away is that like there would be like a little bit more tooling that's part of the like this Jupyter Notebook. One thing that like we're working on is trying to integrate Airflow. So let me show once that got committed here. This is actually going to kick off. Yeah, who here uses Airflow, by the way? Any Airflow users? 1, 2? Oops, git push. All right, so this should kick off an Airflow DAG. Yes, Airflow, again, is this kind of workflow. It's sort of a generic workflow thing. It was created by Airbnb. I just went to a meetup the other day and by someone that, he's actually still works at like Airbnb. He's in like a full Airflow committer. He showed this cool tool that they use at like Airbnb where they actually have a multi-arm bandit, right, like form that like data scientists fill out. Saying, I want this model, so for the prior distributions, start this with 10, this one with 25, and it actually generates all of, like the Airflow, like monitoring. It's basically, it's like one like just simple form and then triggers off all these different things and these tests are like happening all the time and it like gives you this link where you can go and look at the actual like metrics and like the duration of like the experiments and things like that. So that's not open source, unfortunately. I ran up to it because that would have actually saved quite a bit of work. But yeah, people are doing some like pretty crazy stuff with Airflow. And just to give you guys an idea, let me turn on the actual. So once we turn it on, we should, it's basically sitting in Airflow's queue.
Is update prediction meaning replace a prediction, or does it mean training?
This is, so I'm doing a rolling update here. Yeah, so I'll show you guys the code.
Rolling update meaning that?
So there's one model server out there right now. Yeah, this is not the canary model. Like this is actually replacing the existing. So at one point, there's 2 model servers out there with different models. So think of one Docker image per model that's built, and they're all tagged with the like GitHub like commit hash and all that kind of stuff, so you have full traceability back. So
Normally,
here-
if I roll out a model, I might say, for 10,000 records, use the new model as 1%, just as kind of a trial.
Right.
And then after 10,000 records, make it 50%,
Right.
and then full rollout to the new model.
Yeah.
Or
And
some kind of schedule and design of experiment.
yeah, I mean, like you would, right, yeah, it would just be like, some sort of A/B test where you'd want the same users to be hitting the same model, right? So not,
Right.
like, not necessarily like an absolute number, but, like some sort of hash, right? So hash.
Okay, so
hash
that kind of thing is what's happening here.
That's not actually happening. This is just doing like a full-blown like rolling update of like whatever's out there right now.
Okay,
That's the stuff.
so it's completely executing one model. When the next one's ready, then it switches completely to that.
Correct. All right. So let me show you guys what this is doing. This is actually physically doing a rolling update Coopctl command here and giving it the new version of the image, right? All right. Yeah, so again, like there's no product here or anything, right? This is all like, this is mostly just trying to connect these dots and like figure out what sticks at from various places. Okay, so we've got that. We got Airflow. I think, did I show you guys the actual? How much time do we got here?
We could maybe wrap up in like 10 minutes or something?
10
or-
minutes. Okay. Ooh, we got a failure. I think that was from before. All right. So back here. All right, so here's some of the PMML stuff real quick. Actually, I ran this right before when I was sitting up here. So here's what's happening is we're pulling data from S3. We're actually creating a Spark session from the new Spark 2.0 stuff, importing all the features. So the key here is that we're actually deploying a full like pipeline, right? So not just like an individual classifier or something like that, but all new data that comes in now goes through this full pipeline, all the feature normalization, standardization, that kind of thing. Pulling the Airbnb, a portion of the Airbnb data set. The goal here is you give it certain specs about where you live or the place that like you're trying to rent out, and it's going to respond with a price. Cool. So all this, doing a bunch of fun SQL data munging. I'm making you guys sick. Continuous categorical features. So the continuous features, for some reason, bathrooms and bedrooms, I guess, doesn't considered probably
1.5 bathrooms.
Yeah, totally. And I think in the state of California, I remember when I was looking for my place, like it was like 1.2 bathrooms or something. And
I've not heard of
I
that.
didn't know what 1.2 was. It was like all over the place too. And,
The toilet's leaking?
yeah.
It's a urinal.
It's like just the, it's like the men's bathroom now. Splitting the data, doing all the good stuff, standard scaler, one-hot encoding, and of course, at the end of the day, it's all linear regression anyway. Converting, so this is the piece of code here that actually generates from Spark ML. So this is a Spark ML pipeline model, actually org dot like Apache.Spark, whatever ML, and it's generating PMML. So here's a nice big massive PMML.
So that's VLU stuff there, the JPML.
Yeah, it's a JV. Yep. And then from here, I'm calling. So this is the mutable like deployment model. So like there's an existing like model server or cluster of model servers out there. You push the update, it flips in memory, and it's now serving the new model. All right. So let's push it. We got a 200. That's good. Here we're doing the evaluation. So passing in our continuous bathrooms and extra people, I think. Was that continuous too? 1.2 people. And out comes the price. And when I hit that, I should see some stuff light up over here. Let's see, we should see some blipping.
So basically, you're scoring that one record with the value showed on the left in red.
Correct. Oh, the result is here.
Okay.
The inputs are in there. Yep.
So by the way, do you have a specific strategy for both hyperparameter tuning and class validation?
Yeah. At PipelineIO, there's so many people doing that are solving that problem.
Yeah, for different.
So we're focusing on more the deployment side of things. But yeah, and like the sort of interesting thing about these neural networks is that one of the hyperparameters is the actual graph or like the architecture, right? And so, yeah, I mentioned before about these data scientists that want to add, 10, 15 layers. Yeah, that's fine. It's just really training's going to take a lot longer. Scoring's going to take a bit longer.
It's like a wild gap.
Yeah, yeah, for sure. Definitely don't have an answer for that. But here we saw like a little bit of blipping. So here's the Airbnb. I've got a load test here. Let me show this because it's kind of fun. Let's go into Google. I think I have one that's everything, but let me show Amazon real quick. So this is just hitting all of these services with some data. It's all going through the circuit breaker Hystrix library. So this also gives us 90th percentile, 99th percentile, 995. This one's having some trouble here. I'll show that in a sec. This is actually a model where I'm pushing out custom code. So this was a use case I stumbled upon. I was in Spain doing a talk there. And I was talking to this company. They had like an old legacy prediction server, right? And they were starting to rewrite it, but then realized, well, wait a minute, the latency is not that bad. They've tuned it pretty well. It's not updated that often. So they had just a REST endpoint that was into it, and they're like, well, why don't we sort of wrap our service to call that one, and that's part of the Ensemble, and then we do scoring in parallel, and then merge the results. So they needed a way. The performance here is pretty crappy. So the reason why this circuit opened, which is bad, is because I have a timeout of 25 milliseconds, which is why these times come in around 25 milliseconds.
What does circuit open versus circuit closed mean? I'm not familiar with this tricks.
Yeah, so think of the sort of edge service, right? The service that your device is talking to. That's talking to one service, which then internally talks to many other services. Here it's the old legacy prediction service. If that old legacy prediction service, for whatever reason, can't keep up, which is what's happening here, I'm probably doing a JMeter load test, just pounding it, it then flips open the circuit, stops flowing traffic, right? Like lets that dependent service kind of quiet down. And in the meantime, it's serving this fallback, which could just be some sort of generic. For this particular use case, that I talked to him about, it was actually fatal. But this is at least a way to get notified, right? And so I have all these metrics. This was the thing I was most proud of. I have these all piped in, not just into this fancy Netflix dashboard, but also into Grafana, so you can see alongside your other services what's going on. So this I'll explain in a sec. Yeah, so that's kind of the full thing there. I do want to mention, so here's kind of the arbitrary. So this is a simple version, right, of just being able to deploy random Java code. This is a little bit scary, right? Like you wouldn't actually open this up to, the outside world, but yes, internally, if you want to kind of experiment and do multiple, because I keep seeing the same use case where people can't get what they need from PMML, right, or from some other library. So they just want to write custom Python code, custom Java code to stitch these different models together. So this is a really simple version. Here's the predict method. It takes just a general map. The model here is just equals 21619. So let's actually push that out. This is using the library that's used by Spark, actually. It's called Janino. And, so that's actually building up the string. This is actually pushing it out. So here we're calling update. This is the code gen service, so this knows when it gets the string of this name to then compile it on the fly, right? So Janino does this on the fly. Spark uses this to actually do that fusing, right, that I mentioned earlier, where it can see your like logical plan, see that you're doing a map and a filter, instead of the old way, which was building a map function and a filter function and just chaining them together. It physically breaks open the code, fuses them together, and does them all in one Java method. So this is the output, just to say, yeah, everything got compiled okay. Let's see. And then
Maybe
here's,
any wrap up before final questions, or any particular conclusions or points you want to hit on first?
yeah, so there's the arbitrary code. I think I have it. The load test we kind of did. Yes, there's one. So back to, I know this is making me sick. Back to the request batching, or in like like Hystrix land, which is the Netflix open source, is called like request collapsing. So let me show this thing again. So I actually, yeah, so like you can turn on, there's one flag that you pass into TensorFlow server, right, which is turn this on. And then like you can specify other parameters as well too, like the latency, things like that. But here I actually do it within Java, and I'm collapsing the request. So let me just show let me show one way. And okay, so this is where we're doing, I don't think I can zoom in here, but here I'm just doing the simple predict. So what this is doing is, this is actually, so I've preloaded a matrix, right? So think of recommendations. I've got users, right, that are along, so there's like two separate matrices. So I factored the matrices, right? Now I have a user factor matrix, and I've got, right, like the item factor matrix. Each item can be represented with one vector. Every user can be represented with one vector. That's the output of right. So what I'm doing here inside of this method is I'm pulling the users, this user 21619, I'm pulling his vector, I'm pulling the item vector. This is all just from Redis, right. And it's just doing just a simple dot product, right, to get the prediction. So if I just ran this manually, we would see the prediction.
So this is asking a question like, does Greg like movie X?
Exactly, yeah. So this is just the regular prediction. So that's doing it per request. So that's treating each of these separate and just doing this like multiply. This is actually a matrix by a vector, but if you think of two vectors. So we can turn on batch prediction mode, which under normal circumstances, if you just give it low load, it's just going to be essentially the same thing. But so let me actually run this. I want to show, because this is pretty cool. So let's just load up. So this is doing just like single dot product for each request that's coming in. Right. So this gets up. This is about I think 2,000 like per second on this one node. I'm using Amazon's what is it? The R32XLs, 60 gig RAM and 8 cores. So yeah, this is handling each one now. I don't have it set up where you could actually, like this is slightly confusing, but because this seems like this is performing better, but actually I'm handling, if I move to the batch mode, this actually is really handling more requests per second, which from the UI is kind of weird, but like you'll see this thing kind of level off because it really doesn't need to go up to 2,000 per second. Right? So it's just handling one big matrix multiply and then sending back the results.
So in summary, you're showing better throughput
Exactly.
by combining things together into the larger matrix.
Correct.
That's answering multiple requests.
Yep.
By the
And
one
then being able to
matrix.
split them back to the column client. Right. So yeah, this thing
And
levels
so
up here.
before, now your numbers are 89, 90, before they were like 200.
Yeah, and yeah, like it actually goes up even higher than that.
Okay.
So
What's the batch size?
it's actually, the way I have it configured here is 10 milliseconds. So it's by time. Not,
Okay,
yeah,
not
not-
by side, no.
Yeah, Google, inside of TensorFlow serving, they actually have certain heuristics, right, like the empirical stats on what the best batch size is, and I think it like hovers around like 64, right, like they're always like sort of binary like that, so it can do one or the other, but yeah, usually like you want to keep it. And it's just one of those things, yeah, it's like so dependent on your specific workload, right, so.
Well, thank you very much.
Cool.